Okay, so we're starting a new unit, Systems of Equations and Inequalities. That's chapter 8 and 9 of the textbook. So by the end of the unit, you would understand how to solve the system of equations, what is the solution of linear quadratic and quadratic, how to solve these equations both graphically and using algebra. Interpret the situations in real life situations, so application questions. You'll understand these terms. Solve problems involving linear and quadratic inequalities. We'll also talk about that. Sketch the graphs of the inequalities. Explain the strategy to solve them as well. And these are the terms for that. So, lesson 1, solving systems graphically. Key terms over here, system of linear or quadratic equations. So when we have this, that means we have a linear graph and we have a quadratic graph. It could look like this. It could look like this. It could look like this. Okay. Equation types, we have one linear and one quadratic. Your graph features, there will be zero solution, as you can see in the first graph. There can be one solution, as you can see in the second graph. And there can be two solutions, as you can see in the third graph. Okay. The solutions are over here, so your point of intersections. You only have one point of intersection, and you have zero over here because they're not intersecting at all. They never will, right? Just make sure that you have arrows at the end of your graphs whenever you draw them. In the review, I did mention that don't forget about the arrows. Never do. Okay. Okay, when you have quadratic, there will be two quadratic or parabolas, good. Parabolas and quadratics. What happened? Okay, and now the functions, there can be two parabolas that have zero solution. You can have one solution, so parabola that's touching like actually over here. Once, right? You can have two solutions, so something like this, right? You have two solutions. Or the third scenario could be that both the parabolas are on top of each other. So, infinite solutions. Okay? Point, intersecting points. Make sense? So, solution is, when we talk about solution of a quadratic equation, we talked about the x as our solution. When we talk about solution, when there are two system of equations given to us, or two equations given to us, that means the point of intersection will be our solution. So on the graph, it will be point of intersection. And in an equation, it will be the values of the variables that make the equation true. That means they satisfy the equation. How will it satisfy the equation? When left side is equal to right side. Just how we did some verifying questions in quadratics. That's pretty much similar to how you can figure out that the solution is the solution of an equation by checking right side is equal to left side. Okay? Are we good?
You guys okay? Is there like a gas leak over there?
Guys,
I'm gonna just kick you out, please.
I think I need to separate you both.
I didn't. Can you please put it back for a second?
A second.
Relate a system of equations to a context. So we're talking about real life examples here. Which of the following graphs would represent the height of the springboard and her height above the water? So there's a diver who is diving from a 3 feet springboard, a 3 meter springboard. What would the graph look like? Would it be system A, B, C, or D?
I'm assuming D,
Why D?
because she's starting at the height of the springboard and going above it, and then the springboard is going back to the original height right after.
Because why would she start this
Well,
springboard on the water?
That's not the water, that's the springboard.
springboard. Oh,
Yeah, she can't start above the springboard.
Yeah, she cannot start
No,
above
you
the
guys start at the
springboard, right? She's not, when you use the springboard, it's going up and then down, right? So it cannot be another linear equation. The springboard is going down.
Doesn't it come right back up after, so it doesn't work anyway?
What?
The springboard needs
goes
to,
down.
the height of the, like that. It won't change that significantly though. Like the height wouldn't be like 0 because this diver is jumping at the same point. Will it take the springboard so long to come up?
You'll take it like half a second.
Right? So it'll be system D.
Yeah!
And there are 2 point of intersections here. Okay, what does the point of intersection mean in the system here? These point of intersections, what do they tell us?
Like
When she leaves the springboard and then when she is equal with it again?
The height of the springboard, yeah. So the diver's height is equal to the springboard's height. That's what the point of intersection tell us. Okay, so now you guys are supposed to do this question. 2 divers start their dives at the same time. One diver jumps from 1 meter springboard and the other one jumps from a 3 meter springboard. Draw a graph that could model this scenario. Graph the heights above the water over time. So the first thing to do here is just draw a line and then draw another line. Okay, and then we'll have our springboards now. So let's draw 1, 2, 3, 4, 5, 6, and then this is our time and this is our height. So let's say the springboard at 1 meter is over here, and then the springboard at 3. Oh,
Aren't we graphing their heights above the water? Or,
yeah, because they will be going above the water, right?
I thought.
So over here, this wouldn't be that big of a jump, would be like this, right, over time. Because the springboard is small, this would be like that, and the time would be more too, because they'll be in the air for longer. Does that make sense? The springboard stayed constant and the height of the person went up. Wouldn't be that big of a jump again, like might be like this. It's the same thing. Depends upon how much force they're putting, right? Okay. Now we're doing some 10C review stuff, so that things come back to you guys. We are reviewing how to solve linear equations graphically. So this is something you guys have done in grade 10 when 2 equations were given to you and you were supposed to figure out their solution. And what is the solution when 2 equations are given to you?
There's multiple lines.
What?
when two equations are given to you, we do draw lines for each of them. But what's the solution? Intersection point. Good. We just talked about it, right? Over here, point of intersection. We drew some of these. Okay, so what we're going to do is, because it says graphically, we are going to open our graphing calculator. This. Okay. Click on Y1, everyone. You'll put your first equation, which is negative x plus 2, and then half x plus 8, and then we graph it. So this is what it looks like. To figure out my point of intersection, what do I click on?
Second trace 5.
Good. First graph, second graph, this is my guess, and my point of intersection is this. So my solution will be negative 4, 6. Okay, so I can write that down. It'll be negative 4, 6, or you can write x is equal to negative 4, y is equal to 6. But we do need to graph it since there is space given to us, right? And now that can be tedious to figure out each point, but if we do second graph, we can figure out our table, which is very nice. And all now we need to do is 0, 2, put a point at 0, 2, another point at 0, 8, so 0, 2, we have 0, 8 for our second graph. And using the points, you can just graph your first line and the second line. So one of the points is 1, 1 in the pink one over here. This is our pink, and this one is our green graph. Okay, so another point is 2, 0. Then we have 1, 3, 2, negative 2, 4. We have negative 4, 6, negative 3, 5, and so on. So we can draw our line. And then don't forget about the arrows and write down minus x, plus 2 over here. Now we'll draw the points for our green graph. So it's 0, 8, there is negative 2, 7. Then there is 4, 6, negative 4, 6. There is negative 6, 5. And there is 2, 9 as well. So we just graph that. And am I done?
And you see when you go to put the intersection point and the formula on the other line?
Yes. So I put the formula y is equal to half x plus 8. Am I done now? Good. Put the arrows. Okay. That's it. And the steps for it is given to you. For y1, put the first equation, second equation, figure out the points on the table by doing second. The function for this is second graph. Then do second trace 5 to figure out the point of intersection. And look at the table of values for equal y values in both functions. Now we're going to verify this. How can I verify my work? Huh? We drew this using the graphing calculator, and we found our point of intersection using graphing.
Elimination, substitution.
You could, and an easy, that's how we'll figure out our x and y values. But now we're verifying them. To verify them, we'll just put -4, 6 in both our equations, and we would want our left side to be equal to right side. So y is equal to -x plus 2. Put the -4 over here, and then 6 over here. 6 is equal to 4 plus 2. 6 is equal to 6. Left side is equal to right side. Proved, right? We'll do the same thing for the second equation. Y is equal to half x plus 8. Put -4 and 6. So it'll be half -4 plus 8. 2 and 4 is -2 plus 8. So 6 is equal to 6. And left side is equal to right side. Good? Okay. Now, another thing, when we have linear equations or linear system, one equation will be when the slope of the line is different and you know it's going to intersect and have one solution. When the slopes are equal, the lines will be parallel, hence no solution, right? Same slope. Slope is equal, but over here, and same y-intercept, that means you have infinite solution because both the lines look different, but they are the same, okay? Kind of similar to our quadratic piece over here that we talked about, in which intersection is like both the lines are the same, or we have two intersection or one intersection, but we don't have like the slope and parallel line to look at. So over here, how many solutions are there? 0. This 1. So the point of tangency is when the line touches a curve exactly one spot. Okay. 2 intersection points, 2 solution. Both of these are the solutions. Quadratic, first case, how many intersections are there? 0. That means 0 solution. How many intersections are there? 1. So 1 solution. 2 intersections, that means 2 solutions. Awesome. And these lines are called coincidental lines. Yeah, if they're the same, if they're like have the same x and y points, okay? So when we have coincidental lines, or when we have a quadratic graph which is on top of each other too and has the same graph, how many solutions will be there?
Infinite.
Yes, if it's the same graph, we'll have infinite solution. Okay, solution is the, on the graph it is the point of intersection. Good. Okay, so when we are trying to solve a system which has linear and quadratic, or quadratic equations using a graphing calculator, we express the linear equation in the slope-intercept form. So slope-intercept form was y is equal to mx plus b, right? Vertex form was y is equal to ax minus p squared plus q, right? And standard form was y is equal to ax squared plus bx plus c. So you express both your linear equation and quadratic equation in y1, y2. Just remember, we want it in a y equal to format, okay? Because that's how we can input it, right? Graph each the function by entering them as y1 and y2. Use standard window setting for this. Like I was saying, find the point of intersection by second trace 5, like we did before. Or you can do second graph y1 is equal to y2 to figure out where y1 is equal to y2. Okay, and then to check your solution, we verify by doing left side is equal to right side, similar to what we just did and the grade 10 stuff. as well as quadratics too, right? We did left side is equal to right side over there. So let's solve a question. There are two equations given to me. Any questions about how we'll solve this using a graphing calculator? The steps so far? Okay, so two equations are given to us. Are they in the slope-intercept form or standard form? No. So I need to move them around, right? So to change this, I'll have to add y on both sides. So I get 4x plus 3 is equal to y. And the second equation, I'll add y to both sides. It'll be 2x squared plus 8x plus 3 is equal to y. So I have both my equations here. Right? Now, the second step is to input it in my graphing calculator. So let's do that. Y is equal to, let's clear this up. So the first one is going to be 4x plus 3. And the next one is 2x squared plus 8x plus 3, and we graph it. So this is what our graph looks like. To figure out my vortex, it'll be second trace. Vortex. Minimum. Good. So that'll be 3. So that's my left bound, and this is my right bound, and this is my vortex. So it is 2 and -5, so I can plot that. -2 and -5. Somewhere over here. And then I have the point of intersection at second trace 5. First curve, second curve, guess. And it is at -2 and -5. Next one, second trace 5, has two solutions. -3.55, E -15, that's just 0, and 3.
Let's
So
see.
1, 2.
When I put that in the graph function, it just said 0.
Oh, I don't know why it said different for me. Okay, so we'll draw a straight line that's crossing this. So it'll be like that. The points, right? And that was my 4x plus 3 is equal to y graph. And my parabola will be like that. Oh, would want my vortex over here too, right? So something like this. That doesn't look good. Okay, there you go. Okay, that's my parabola. And these are my point of intersection. So I need to put a label on my graph and say 0, 3 and -2, -5. Okay, and that's how, and that's it. That's all we need to do. Good. Now we need to verify if our solution was correct or not. Since in this case, do we have one solution or two solutions? 2. So we'll have to do it for both of them. So we have 0, 3. I'll draw a separate line for -2, -5. Put it in the first equation, 4x minus y plus 3. So replace that by my values. X is -2, y is -5. 4 minus 2 is -4 times -2 is -8. Negative times negative is positive. 5 plus 3. So -8 plus 5 plus 3 is 0 is equal to 0. left side is equal to right side. So the first equation do say that -2 comma -5 is part of the solution. For the second equation, it's 2 times -2 squared plus 8 times -2 minus 5 plus 3 is equal to 0. So when I input that in the calculator, I'll get 8 minus 16 plus 5 plus 3 is equal to 0. That's 0 is equal to 0. Left side is right side, equal to right side. So that means this solution is correct. I verified it. Now I need to do the same for my 0, 3. Question?
Yes. Like, why did you put 2, -2 there? Yeah. So you just do why?
Because this is the equation. So I inputted x.
You have to put it in. Okay.
Yeah. So you put -5 and -2. Yeah. Same thing over here, 0 and 3. So I put in 0, 0 squared plus 8 times 0 minus 3 plus 3. So 0, anything times 0 is 0. 0 plus 0 minus 3 plus 3 is 0. That means left side is equal to right side. Do the same for my first equation. So 4 times 0 minus 3, because that's my y, plus 3. 0 minus 3 plus 3 is equal to 0. Left side is equal to right side. Hence, I've verified that this solution is also correct. Okay, whenever it's asking you to verify, put in the values, and if left side is equal to right side, it's correct. Okay, we'll do one more question. So in this case, we have 2 quadratic equations given to us. Okay, are they in the standard or vertex form? So I have to make them be in that form. So I'll add y to both sides, and I'll add 35 to both sides. 35 minus 35 is 0. Y minus y is, y minus y is 0. So we have 2x squared minus 16x plus 35 is equal to y. Is it in standard form now? Okay, I'll do the same thing over here. Add 11 and add y. So minus 11 plus 11 is 0. Minus y plus y is 0. So we have 2x squared minus 8x plus 11 is equal to y. Okay. Now we'll use our graphing calculator to graph these points. So we go y1, clear, clear, clear. And then we go and put in our values. So we have 2x squared minus 16x plus 35, and the second one is 2x squared minus 8x plus 11, and we graph it. This is what my equation looks like. So I do second trace 5. It's not in the window, so I'll have to bring it down to see if it's actually there. So there you go. And the second curve is at, so I can tell that it's at y is equal to 18.5. So I need to bring it down. So there it go. Okay, and then this is my point of intersection, which is 3, 5. So let's do that. 1, 2, 3. 1, 2, 3, 4, 5. This is my point of intersection, and my second curve is black in color, so it'll be like over here, and then my first one is over here, and that's my point of intersection. 3, 5. That's it. I want to see you guys verify this solution. right now. It's only 1 point, so it shouldn't take that long. Try doing it, and then I'll give you guys some time to do question 3, your turn question 3 as well. Okay?